Hello! Today we are diving into the world of descriptive statistics. By the end of this lesson, you will be able to calculate and interpret measures of center, position, and variability for quantitative data. We will also learn how to identify outliers and choose the best statistics to describe a dataset. These are the core skills for Topic 1.7 of the AP Statistics curriculum. Let's get started. The first thing we often want to know about a dataset is, where is the middle? We use measures of center to describe this. The two most common measures are the mean and the median. The mean, denoted as x bar for a sample, is the arithmetic average. Mathematically, we sum all the individual data points, represented by x sub I, and divide by the total number of values, n. The median is the literal middle value of an ordered dataset. If you have an odd number of values, the median is the value exactly in the center. If you have an even number of values, we take the mean of the two middle values. Let's look at a quick example. To find the mean, we add 5, 12, 7, 14, and 2 to get 40, then divide by 5. Our mean is 8. To find the median, we first sort the data. The value in the middle position is 7. Beyond the center, we need to describe the position of specific data points. We do this using percentiles and quartiles. The p percentile is the value such that p% of the data is less than or equal to it. To get a full picture of position, we use the 5-number summary: the minimum, quartile 1, the median, quartile 3, and the maximum. The minimum is the smallest value, and the maximum is the largest value in the sorted set. Quartile 1, or Q1, is the median of the lower half of the data. It represents the 25th percentile. Quartile 3, or Q3, is the median of the upper half of the data, representing the 75th percentile. Notice how these quartiles divide the data into 4 equal-sized groups. Q1 and Q3 are the boundaries for the middle 50% of the data. Knowing the center isn't enough. We also need to know how spread out the data is. This is called variability. We will focus on 3 main measures: range, interquartile range, and standard deviation. The range is the simplest measure. It is just the distance between the largest and smallest values. The interquartile range, or IQR, measures the spread of the middle 50% of the data. We calculate it by subtracting Q1 from Q3. The standard deviation represents the typical distance of the data values from their mean. To calculate it, we find the difference between each point and the mean, square those differences, sum them up, divide by n-1, and finally take the square root. If you square the standard deviation, you get what we call the sample variance. A small standard deviation means the data points are clustered closely around the mean, while a large one means they are spread far apart. Sometimes, a dataset contains unusual values that fall far away from the rest of the data. We call these outliers. In AP Statistics, we have a very specific rule to identify them. To find potential outliers, we first calculate the interquartile range. Then, we establish boundaries called fences. The lower fence is Q1 minus 1.5 times the IQR. The upper fence is Q3 plus 1.5 times the IQR. Any data point that falls outside these two fences is considered a mathematical outlier. Another common method is to flag any value located more than 2 standard deviations above or below the mean. However, the 1.5 times IQR rule is the most frequent method you'll be asked to use on the exam. Let's try an example. Suppose we have this data. The IQR is 5. 1.5 times the IQR is 7.5. Our upper fence is 27.5. Since 50 is much larger than 27.5, 50 is an outlier. One of the most important decisions a statistician makes is choosing which summary statistic to use. This choice depends on whether a statistic is resistant to outliers. A statistic is resistant, or robust, if its value does not change significantly when an outlier is added to the dataset. The median and the IQR are resistant. Because the median only cares about the middle position, and the IQR only looks at the middle 50%, a massive outlier at the far end of the data won't move them much, if at all. On the other hand, the mean, standard deviation, and range are non-resistant. Think about it. If we take a small dataset and add a value of 100, the mean will jump significantly to account for that large value. Similarly, the standard deviation will skyrocket because that outlier is very far from the mean. As a rule of thumb, if your data is skewed or has clear outliers, use the median and IQR to describe the center and spread. If the data is roughly symmetric and has no outliers, the mean and standard deviation are the preferred measures. Finally, let's discuss what happens to our statistics when we change the units of measurement, such as converting inches to centimeters or adding a constant bonus to every test score. If you add or subtract a constant value, let's call it A, to every data point, the measures of center and position change by that same amount. The new mean is the old mean plus A. The new median is the old median plus A. And the new percentiles are the old percentiles plus A. Basically, the entire distribution shifts left or right on the number line. However, adding a constant does not change the variability. The distance between the points remains exactly the same, so the range, IQR, and standard deviation do not change. Now, if you multiply or divide every data point by a constant b, every single statistic we've discussed is affected. The new mean, median, standard deviation, and IQR are all the old values multiplied by b. Both the center and the spread are scaled by that factor. This is a critical concept for the AP exam. Always remember, measures of center shift and scale, but measures of spread only scale. You have now mastered topic 1.7. You can now calculate measures of center, position, and variability, identify outliers, and choose the most appropriate statistics for any quantitative dataset. Great job!